Meteoroid. A meteoroid is a small rocky or metallic body in outer space. Meteoroids are distinguished as objects significantly smaller than asteroids, ranging in size from grains to objects up to a meter wide. Objects smaller than meteoroids are classified as micrometeoroids or space dust. Many are fragments from comets or asteroids, whereas others are collision impact debris ejected from bodies such as the Moon or Mars. A meteor or shooting star is the visible passage of a meteoroid, comet, or asteroid entering Earth's atmosphere. At a speed typically in excess of 20 km per second, 72,000 km per hour, 45,000 miles per hour, aerodynamic heating of that object produces a streak of light, both from the glowing object and the trail of glowing particles that it leaves in its wake. Meteors typically become visible when they are about 100 kilometers, 62 miles, above sea level. A series of many meteors appearing seconds or minutes apart and appearing to originate from the same fixed point in the sky is called a meteor shower. An estimated 25 million meteoroids, micrometeoroids and other space debris enter Earth's atmosphere each day, which results in an estimated 15,000 tons of that material entering the atmosphere each year. A meteorite is the remains of a meteoroid that has survived the ablation of its surface material during its passage through the atmosphere as a meteor and has impacted the ground. Meteoroids. In 1961, the International Astronomical Union (IAU) defined a meteoroid as a solid object moving in interplanetary space, of a size considerably smaller than an asteroid and considerably larger than an atom. In 1995, Beach and Steele, writing in the Quarterly Journal of the Royal Astronomical Society, proposed a new definition where a meteoroid would be between 100 m and 10 meters, 33 feet, across. In 2010, following the discovery of asteroids below 10 meters in size, Rubin and Grossman proposed a revision of the previous definition of meteoroid to objects between 10 m, 0.00039 in, and 1 meter, 3 feet 3 in diameter in order to maintain the distinction. According to Rubin and Grossman, the minimum size of an asteroid is given by what can be discovered from Earth-bound telescopes, so the distinction between meteoroid and asteroid is fuzzy. Some of the smallest asteroids discovered, based on absolute magnitude h, are 2008 TS26 with h equals 33.2 and 2011 CQ1 with h equals 32.1, both with an estimated size of 1 m, 3 feet 3 in. In April 2017, the IAU adopted an official revision of its definition, limiting size to between 30 m, 0.0012 in, and 1 meter in diameter, but allowing for a deviation for any object causing a meteor. Objects smaller than meteoroids are classified as micrometeoroids and interplanetary dust. The Minor Planet Center does not use the term meteoroid. Composition. Almost all meteoroids contain extraterrestrial nickel and iron. They have three main classifications: iron, stone, and stony iron. Some stone meteoroids contain grain-like inclusions known as chondrules and are called chondrites. Stony meteoroids without these features are called achondrites, which are typically formed from extraterrestrial igneous activity. They contain little or no extraterrestrial iron. The composition of meteoroids can be inferred as they pass through Earth's atmosphere from their trajectories and the light spectra of the resulting meteor. Their effects on radio signals also give information, especially useful for daytime meteors, which are otherwise very difficult to observe. From these trajectory measurements, meteoroids have been found to have many different orbits, some clustering in streams, see meteor showers, often associated with a parent comet, others apparently sporadic. Debris from meteoroid streams may eventually be scattered into other orbits. The light spectra, combined with trajectory and light curve measurements, have yielded various compositions and densities, ranging from fragile snowball-like objects with density about a quarter that of ice, to nickel-iron-rich dense rocks. The study of meteorites also gives insights into the composition of non-ephemeral meteoroids. In the Solar System, Most meteoroids come from the asteroid belt, having been perturbed by the gravitational influences of planets, but others are particles from comets, giving rise to meteor showers. Some meteoroids are fragments from bodies such as Mars or the Moon, that have been thrown into space by an impact. Meteoroids travel around the Sun in a variety of orbits and at various velocities. The fastest move at about 42 km per second, 94,000 miles per hour, through space in the vicinity of Earth's orbit. This is escape velocity from the Sun, equal to the square root of 2 times Earth's speed, and is the upper speed limit of objects in the vicinity of Earth, unless they come from interstellar space. Earth travels at about 29.6 km per second, 66,000 miles per hour, so when meteoroids meet the atmosphere head-on, which only occurs when meteors are in a retrograde orbit such as the Leonids, which are associated with the retrograde comet 55P/Tempel-Tuttle, the combined speed may reach about 71 km per second, 160,000 miles per hour, see specific energy #astrodynamics. Meteoroids moving through Earth's orbital space average about 20 km per second, 45,000 miles per hour, but due to Earth's gravity meteors such as the Phoenicids can make atmospheric entry at as slow as about 11 km per second. On January 17, 2013, at 5:21 PST, a 1-meter-sized comet from the Oort cloud entered Earth's atmosphere over California and Nevada. The object had a retrograde orbit with perihelion at 0.98 ± 0.03 astronomical units. It approached from the direction of the constellation Virgo, which was in the south about 50 degrees above the horizon at the time, and collided head-on with Earth's atmosphere at 72 ± 6 km per second, 161,000 ± 13,000 miles per hour, vaporizing more than 100 kilometers, 330,000 feet, above ground over a period of several seconds. Collision with Earth's atmosphere. When meteoroids intersect with Earth's atmosphere at night, they are likely to become visible as meteors. If meteoroids survive the entry through the atmosphere and reach Earth's surface, they are called meteorites. Meteorites are transformed in structure and chemistry by the heat of entry and force of impact. A noted 4-meter, 13 feet, asteroid, 2008 TC3, was observed in space on a collision course with Earth on 6 October 2008 and entered Earth's atmosphere the next day, striking a remote area of northern Sudan. It was the first time that a meteoroid had been observed in space and tracked prior to impacting Earth. NASA has produced a map showing the most notable asteroid collisions with Earth and its atmosphere from 1994 to 2013 from data gathered by U.S. government sensors, see below. Meteors. A meteor, known colloquially as a shooting star or falling star, is the visible passage of a glowing meteoroid, micrometeoroid, comet or asteroid through Earth's atmosphere, after being heated to incandescence by collisions with air molecules in the upper atmosphere, creating a streak of light via its rapid motion and sometimes also by shedding glowing material in its wake. Although a meteor may seem to be a few thousand feet from the Earth, meteors typically occur in the mesosphere at altitudes from 76 to 100 kilometers, 250,000 to 330,000 feet. The root word meteor comes from the Greek meteoros, meaning high in the air. Millions of meteors occur in Earth's atmosphere daily. Most meteoroids that cause meteors are about the size of a grain of sand, i.e. they are usually millimeter-sized or smaller. Meteoroid sizes can be calculated from their mass and density which, in turn, can be estimated from the observed meteor trajectory in the upper atmosphere. Meteors may occur in showers, which arise when Earth passes through a stream of debris left by a comet, or as random or sporadic meteors, not associated with a specific stream of space debris. A number of specific meteors have been observed, largely by members of the public and largely by accident, but with enough detail that orbits of the meteoroids producing the meteors have been calculated. The atmospheric velocities of meteors result from the movement of Earth around the Sun at about 30 km per second, 67,000 miles per hour, the orbital speeds of meteoroids, and the gravity well of Earth. Meteors become visible between about 75 to 120 km, 250,000 to 390,000 feet, above Earth. They usually disintegrate at altitudes of 50 to 95 km, 160,000 to 310,000 feet. Meteors have roughly a 50% chance of a daylight, or near daylight, collision with Earth. Most meteors are, however, observed at night, when darkness allows fainter objects to be recognized. For bodies with a size scale larger than 10 cm, 3.9 in, to several meters, meteor visibility is due to the atmospheric ram pressure, not friction, that heats the meteoroid so that it glows and creates a shining trail of gases and melted meteoroid particles. The gases include vaporized meteoroid material and atmospheric gases that heat up when the meteoroid passes through the atmosphere. Most meteors glow for about a second. History. Meteors were not known to be an astronomical phenomenon until early in the 19th century. Before that, they were seen in the West as an atmospheric phenomenon, like lightning, and were not connected with strange stories of rocks falling from the sky. In 1807, Yale University chemistry professor Benjamin Silliman investigated a meteorite that fell in western Connecticut. Silliman believed the meteor had a cosmic origin, but meteors did not attract much attention from astronomers until the spectacular meteor storm of November 1833. People all across the eastern United States saw thousands of meteors, radiating from a single point in the sky. Careful observers noticed that the radiant, as the point is called, moved with the stars, staying in the constellation Leo. The astronomer Denison Olmsted extensively studied this storm, concluding that it had a cosmic origin. After reviewing historical records, Heinrich Wilhelm Matthias Olbers predicted the storm's return in 1867, drawing other astronomers' attention to the phenomenon. Hubert A. Newton's more thorough historical work led to a refined prediction of 1866, which proved correct. With Giovanni Schiaparelli's success in connecting the Leonids, as they are called, with Comet Tempel-Tuttle, the cosmic origin of meteors was firmly established. Still, they remain an atmospheric phenomenon and retain their name meteor from the Greek word for atmospheric, fireball. A fireball is a brighter than usual meteor that also becomes visible when about 100 kilometers from sea level. The International Astronomical Union, IAU, defines a fireball as a meteor brighter than any of the planets, apparent magnitude -4 or greater. The International Meteor Organization, an amateur organization that studies meteors, has a more rigid definition. It defines a fireball as a meteor that would have a magnitude of -3 or brighter if seen at zenith. This definition corrects for the greater distance between an observer and a meteor near the horizon. For example, a meteor of magnitude -1 at 5 degrees above the horizon would be classified as a fireball because, if the observer had been directly below the meteor, it would have appeared as magnitude -6. Fireballs reaching apparent magnitude -14 or brighter are called bolides. The IAU has no official definition of bolide, and generally considers the term synonymous with fireball. Astronomers often use bolide to identify an exceptionally bright fireball, particularly one that explodes in a meteor airburst. They are sometimes called detonating fireballs. It may also be used to mean a fireball which creates audible sounds. In the late 20th century, bolide has also come to mean any object that hits Earth and explodes, with no regard to its composition, asteroid or comet. The word bolide comes from the Greek beta omicron lambda sigma, boles, which can mean a missile or to flash. If the magnitude of a bolide reaches -17 or brighter, it is known as a superbolide. A relatively small percentage of fireballs hit Earth's atmosphere and then pass out again. These are termed Earth-grazing fireballs. Such an event happened in broad daylight over North America in 1972. Another air phenomenon is a meteor procession, where the meteor breaks up into several fireballs traveling nearly parallel to the surface of Earth. A steadily growing number of fireballs are recorded at the American Meteor Society every year. There are probably more than 500,000 fireballs a year, but most go unnoticed because most occur over the ocean and half occur during daytime. A European Fireball Network and a NASA All-Sky Fireball Network detect and track many fireballs. Effect on atmosphere. The entry of meteoroids into Earth's atmosphere produces three main effects: ionization of atmospheric molecules, dust that the meteoroid sheds, and the sound of passage. During the entry of a meteoroid or asteroid into the upper atmosphere, an ionization trail is created, where the air molecules are ionized by the passage of the meteor. Such ionization trails can last up to 45 minutes at a time. Small, sand grain-sized meteoroids are entering the atmosphere constantly, essentially every few seconds in any given region of the atmosphere, and thus ionization trails can be found in the upper atmosphere more or less continuously. When radio waves are bounced off these trails, it is called meteor burst communications. Meteor radars can measure atmospheric density and winds by measuring the decay rate and Doppler shift of a meteor trail. Most meteoroids burn up when they enter the atmosphere. The leftover debris is called meteoric dust or just meteor dust. Meteor dust particles can persist in the atmosphere for up to several months. These particles might affect climate, both by scattering electromagnetic radiation and by catalyzing chemical reactions in the upper atmosphere. Meteoroids or their fragments achieve dark flight after deceleration to terminal velocity. Dark flight starts when they decelerate to about 2 to 4 km per second, 4,500 to 8,900 miles per hour. Larger fragments fall further down the strewn field. Colors. The visible light produced by a meteor may take on various hues, depending on the chemical composition of the meteoroid, and the speed of its movement through the atmosphere. As layers of the meteoroid abrade and ionize, the color of the light emitted may change according to the layering of minerals. Colors of meteors depend on the relative influence of the metallic content of the meteoroid versus the superheated air plasma, which its passage engenders: orange-yellow, sodium yellow, iron blue-green, magnesium violet, calcium red, atmospheric nitrogen and oxygen. Acoustic manifestations. The sound generated by a meteor in the upper atmosphere, such as a sonic boom, typically arrives many seconds after the visual light from a meteor disappears. Occasionally, as with the Leonid meteor shower of 2001, crackling, swishing, or hissing sounds have been reported, occurring at the same instant as a meteor flare. Similar sounds have also been reported during intense displays of Earth's auroras. Theories on the generation of these sounds may partially explain them. For example, scientists at NASA suggested that the turbulent ionized wake of a meteor interacts with Earth's magnetic field, generating pulses of radio waves. As the trail dissipates, megawatts of electromagnetic power could be released, with a peak in the power spectrum at audio frequencies. Physical vibrations induced by the electromagnetic impulses would then be heard if they are powerful enough to make grasses, plants, eyeglass frames, the hearer's own body, see microwave auditory effect, and other conductive materials vibrate. This proposed mechanism, although proven plausible by laboratory work, remains unsupported by corresponding measurements in the field. Sound recordings made under controlled conditions in Mongolia in 1998 support the contention that the sounds are real. Also see bolide. Meteor shower. A meteor shower is the result of an interaction between a planet, such as Earth, and streams of debris from a comet or other source. The passage of Earth through cosmic debris from comets and other sources is a recurring event in many cases. Comets can produce debris by water vapor drag, as demonstrated by Fred Whipple in 1951, and by breakup. Each time a comet swings by the Sun in its orbit, some of its ice vaporizes and a certain amount of meteoroids are shed. The meteoroids spread out along the entire orbit of the comet to form a meteoroid stream, also known as a dust trail, as opposed to a comet's dust tail caused by the very small particles that are quickly blown away by solar radiation pressure. The frequency of fireball sightings increases by about 10 to 30% during the weeks of vernal equinox. Even meteorite falls are more common during the northern hemisphere's spring season. Although this phenomenon has been known for quite some time, the reason behind the anomaly is not fully understood by scientists. Some researchers attribute this to an intrinsic variation in the meteoroid population along Earth's orbit, with a peak in big fireball producing debris around spring and early summer. Others have pointed out that during this period the ecliptic is, in the northern hemisphere, high in the sky in the late afternoon and early evening. This means that fireball radiants with an asteroidal source are high in the sky, facilitating relatively high rates, at the moment the meteoroids catch up with Earth, coming from behind going in the same direction as Earth. This causes relatively low relative speeds, and from this low entry speeds, which facilitates survival of meteorites. It also generates high fireball rates in the early evening, increasing chances of eyewitness reports. This explains a part, but perhaps not all, of the seasonal variation. Research is in progress for mapping the orbits of the meteors to gain a better understanding of the phenomenon. Notable meteors. Gallery of meteors. Meteorites. A meteorite is a portion of a meteoroid or asteroid that survives its passage through the atmosphere and hits the ground without being destroyed. Meteorites are sometimes, but not always, found in association with hypervelocity impact craters. During energetic collisions, the entire impactor may be vaporized, leaving no meteorites. Geologists use the term bolide in a different sense from astronomers to indicate a very large impactor. For example, the USGS uses the term to mean a generic large crater-forming projectile in a manner to imply that we do not know the precise nature of the impacting body, whether it is a rocky or metallic asteroid, or an icy comet for example. Meteoroids also hit other bodies in the solar system. On such stony bodies as the Moon or Mars that have little or no atmosphere, they leave enduring craters. Impact craters. Meteoroid collisions with solid solar system objects, including the Moon, Mercury, Callisto, Ganymede, and most small moons and asteroids, create impact craters, which are the dominant geographic features of many of those objects. On other planets and moons with active surface geological processes, such as Earth, Venus, Mars, Europa, Io, and Titan, visible impact craters may become eroded, buried, or transformed by tectonics over time. In early literature, before the significance of impact cratering was widely recognized, the terms cryptoexplosion or cryptovolcanic structure were often used to describe what are now recognized as impact-related features on Earth. Molten terrestrial material ejected from a meteorite impact crater can cool and solidify into an object known as a tektite. These are often mistaken for meteorites. Gallery of meteorites.